Lesson 19, Triangle Congruence. Your objectives are to apply angle, side, angle, angle, side, and HL to construct triangles and solve problems. You're going to prove triangles congruent by using ASA, AAS, and HL, and use CPCTC to prove parts of triangles are congruent. Your vocabulary are included side and CPCTC. So let's start with included side. An included side is the common side of two consecutive angles in a polygon. The following postulate uses the idea of an included side. PQ is the included side of angles P and Q. So it would be the side that touches the vertices of the two angles you're looking at. And the postulate that we were looking at is the angle-side-angle congruence postulate. And it states that if two angles and the included side of one triangle are congruent, then the triangles are congruent. So if you have two triangles that each have two angles and the corresponding included side congruent, then you can automatically use angle, side, angle to state that the two triangles are congruent. Let's look at an example of problem solving. A mailman has to collect mail from boxes at A and B and drop it off at the post office at C. Does the table give enough information to determine the location of the mailboxes in the post office? Well, let's look at the table. We have A to B gives us a bearing and distance. B to C gives us a bearing but no distance yet. And C to A gives us another bearing but no distance. So let's think about this. First of all, we need to understand the problem. The answer is whether the information in the table can be used to find the position points of A, B, and C. So we're going to list the important information. The bearing from A to B is north 65 degrees east. From B to C is north 24 degrees west. And from C to A is south 20 degrees west. And the distance from A to B is 8 miles. Step 2, we need to make a plan. It's hard to solve any problem without a plan. So let's draw the mailman's route using vertical lines and show the north-south directions. Then we'll use parallel lines and an alternate interior angles to help find the angle measures of triangle ABC. So let's solve this. The measure of CAB is 65 degrees minus 20 degrees, so that's 45. The measure of CAB is 180 minus the 24 plus 65, which is 91. We know the measures from CAB and CBA and the length of the included side AB. Therefore, by ASA, a unique triangle ABC is determined. Let's look back. One and only one triangle can be made using the information in the table. So the table does give enough information to determine the location of the mailboxes and the post office. Let's look at another example. We're going to determine if we can use ASA to prove the triangles congruent and explain. So we see here that we have these two small angles in the two triangles are congruent. And these are congruent at the top, which means that this is a bisector, and it's congruent to itself. But the included sides would be from the vertex down to each of the small points. We don't know anything about that. The two congruent angle pairs are given, but the included sides are not given as congruent. Therefore, you cannot use ASA to prove that the triangles are congruent. You can use the third angles theorem to prove another congruence relationship based on angle-side-angle. This is called the angle-angle-side and also the third angles theorem. Okay? So if two angles and a non-included side of one angle are congruent to the corresponding angles, and the non-included side of another triangle, then the triangles are congruent. So using this theorem, we could have proven that the other two triangles before were congruent, because we know that the middle sides are congruent to each other. It's a non-included side. So let's look at this. If we are given angle G is congruent to angle K, angle J is congruent to angle M, and segment HJ is congruent to LM, we want to prove that they are congruent triangles, and we can use the third angles theorem in this case. We first start out with the two angles that we know that are congruent, G and K and J and M. And then we know that there's a third side that's congruent, H is congruent to L, and that we use the third angles theorem for that. HJ is congruent to LM, that was given. And then we have that if we have that given, then we do have included angles, and we can say by angle side angle from steps 1, 3, and 2, these two triangles are congruent. By being able to prove that H and L are congruent, it gives us an included side. So let's use the angle side to prove triangles congruent. And you see we have a big triangle with 3 small triangles inside. We want to use angle side to prove the triangles congruent. And we're given that angle X is congruent to angle V, YZW is congruent to YWZ, and XY is congruent to VY. We want to prove that triangle XYZ and VYW are congruent. We can do a flowchart proof for this, and we can show that if we start up here, we have angle XYZ is supplemental to YZW. So XYZ and YZW, these two angles are supplementary. That's the definition of supplementary angles. They form a line. And then from that we can say that the angle YZX is congruent to YWV just by using YZW and YWZ are congruent here. So we were given this. And then we also know that we have VWY, this one is also supplemental to YWZ, and that's definitions. And then we're given that X and Z and V are congruent, so we have those that are congruent, and that XY and VY are congruent. This gives us angle side, and they are congruent triangles. Another congruence postulate is the hypotenuse leg, or HL congruence postulate. If the hypotenuse of and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. Note, this only works for right triangles. Let's determine if we can use the hypotenuse leg congruence theorem to prove the triangles congruent. And if not, what else do we need to know? So, let's look at our triangle. We know that the hypotenuses of these two triangles are congruent. We know that they are both right triangles because these are supplementary angles, and one is 90, so the other is 90. And we can also say that this leg in the center of the two triangles that they share is congruent to itself by the reflexive property. So yes, we can use the hypotenuse leg congruence theorem. We have the right angles, and they share one leg. The hypotenuses are congruent, therefore the triangles are congruent by the hypotenuse leg congruence theorem. Let's apply this and see if we can prove these two triangles to be congruent. Well, they both have one leg congruent to the other and an angle congruent. Can we somehow prove that these hypotenuse is congruent to the other hypotenuse? No, we cannot. There's no measurement, not enough information has been given to us to say that these are congruent. CPC-TC is an abbreviation. It stands for the phrase corresponding parts of congruent triangles are congruent. It can be used as a justification in a proof after you have proven two triangles congruent. Remember, side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg congruence use corresponding parts to prove triangles congruent. CPC-TC uses congruent triangles to prove corresponding parts. So it's kind of like when we can prove that lines are that angles are congruent because of parallel lines being cut by a transversal, but to prove the lines are parallel, we would use the converse postulates. CPC-TC is kind of like that. We can use that these congruent triangles, these are the same, we're given that, then that means that each of their parts must be congruent as well. Let's look at an engineering application. A and B are on the edges of a ravine. What is the length of AB? One angle pair is congruent because they are vertical angles. So these in the center, these are congruent angles. Two pairs of sides are congruent because their lengths are equal. We were given that this side is 15 miles, and so is this. 10 miles here and 10 miles here. So we have side, angle, side. They are congruent by side, angle, side, which means that by the corresponding parts of congruent triangles, we can say that the third side pair is congruent, so AB equals 18 miles, because this will be congruent to the side over here. If we want to prove corresponding parts congruent, and we're given YW bisects XZ, XY is congruent to YZ, we want to prove that angle XYW is congruent to CYW. We can write a nice flowchart proof here. YW bisects XZ. This is given. Then we also know that XW is congruent to ZW, and this would be an X on this side, but not shown. So these two edges of the triangle are congruent, and that's the definition of a bisector. Then we know that XYE is congruent to YZ, and that's because it was given. We also know that YW and WY are congruent because of the reflexive property of congruence. And so that means that the two triangles are congruent by side, 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 and their angles are congruent by CPC-TC. Work backward when you're planning a proof. To show that ED is parallel to GF, look for a pair of angles that are congruent. Then look for triangles that contain these angles. For example, let's use CPCTC in a proof. Given that NO is parallel to MN and angle N is congruent to angle P, we want to prove that MN is parallel to OP. Our first thing will be that angle N is congruent to angle P and NO is parallel to MP. This is given. Next, we can say that NOM is congruent to PMO by the alternate interior angles theorem. MO is congruent to itself by the reflexive property of congruence. Triangle MNO is congruent to triangle OPM. This is by angle, angle, side, and therefore we have that NMO is congruent to angle POM by corresponding parts of congruent triangles congruence. And that gives us then that MN is parallel to OP by the converse of the alternate interior angles theorem. You need to remember all those theorems we've been learning and their converses so that you can write these proofs easily. Let's look at another example. We are given some coordinates D, E, F, G, H, and I, and we want to prove that angle DEF is congruent to GHI. Well, step one, we need to plot our points on a coordinate plane. We have two triangles. So we want DEF, where angle E, is congruent to GHI. So we want angle E congruent to angle H. That's what we're trying to find. So step 2 is to use the distance formula to find the lengths of the sides of each triangle. The distance formula, remember, is x2 minus x1 squared plus y2 minus y1 quantity squared, and then we take the square root of all of that information. Okay. So you can see that DE is congruent to GH, EF is congruent to HI, and DF is congruent to GI. Therefore, the triangles are congruent by side, 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 and the angles are congruent by CPCTC. Now, you try. Here's some more. And one more page. For next class, please complete the You Try problems. We'll check your answers during class. Bring your notes to class and be prepared to work triangle congruence problems.